Okay, so today what we're gonna do is we're gonna talk about lesson number 3, which is orders of operation. So we did a little bit about, talked about the integers, right? We know how to combine them, we add and subtract, right? And then we also learn how to multiply and divide, and you know the rules there. Now what we're gonna do is we're gonna do the orders of operations, and orders of operation, and I'm pretty sure some of you, even probably most of you, have heard of this one before. What we're going to do is we're going to review it and make sure that we really understand this piece. So orders of operation, our main goal is to use BEDMAS to evaluate the math expression. Now, I'm going to talk about the word BEDMAS here. This one here is an acronym. The word BEDMAS is an acronym so that we can remember the particular order in which one we're going to do first. Okay? Who has participated in some kind of a draw, and then sometimes they say, oh, you have a skill testing required? You've done that, right? Sometimes you put a name on a draw, and then there's like a math question, answer this, and it's usually the orders of operation. Yes? Yeah. They never ask trigonometry, right? But orders of operation, who knows? Like, you never know. Like, this will come pretty handy for sure. So, BEDMAS. So we're going to talk about that right away. And evaluate. We're going to see that quite a bit. What does evaluate mean? Now, if you are trying to take apart the word evaluate, the root word of evaluate means value. Okay, the root word of evaluate is value. What is it worth? Okay, so when you see this, evaluate, the root word is value. Means what is it worth? Okay, you're gonna see that quite a bit. Value or evaluate means find out the answer. So the other thing is that another goal for today is use orders of operations, which is BEDMAS, to solve word problems. I don't know about you, but if I keep saying word problems, I feel like I want to say world problems. Word problems. Okay, so here we go. What is BEDMAS? When you have mixed operations, we have to put them in a specific order or do them in a specific order. So operations that we know of are add, subtract, multiply, and divide. We know that. But at the same time, we also have the exponents. Yes? What are the exponents? Square root is an exponent. Yes, square root is technically an exponent. What else is an exponent? Cube. Square, right? So those are the exponents part. So here, you must follow the order. The short form is BEDMAS. So the B stands for brackets. It means that if you see a brackets, and inside that bracket, there's some kind of a math involved in there, some questions in there, operation, you gotta do those ones first. That's why it says brackets, whatever's inside the brackets. So that's the B. The E are the exponents, and we kind of discussed that a little bit. We said exponents when you see a square, cube, or square root, a cube root. Those are the exponents. The D and M are multiplication and division, and if you see just multiplication and division, you're going to do that from left to right. And then the A and the S are addition and subtraction. So you do the addition and subtraction last. So here's an example. Example number 1. what can we do first? We're gonna do the brackets first. So let's work out whatever's inside the brackets right here. So it's gonna be 3 times 11 minus 11. So we work out whatever's inside the brackets first, and then the rest that we haven't done, we'll just write it down. Okay? So we did the brackets. So we got brackets. What else? What's the next thing that we gotta do? Are there any exponents? No exponents. What's next? This is an interesting one because brackets here indicates what? Multiplication, right? So that means this brackets here indicates multiplication. So do this part here. This is a multiplication piece. 3 times 11, which is 33, minus 11. And then 33 minus 11 is 22. So the answer is 22. Okay. Any questions there? I'm gonna ask you this. What's this?
Can we multiply before we add them while they are in the bracket? Like, let's say 3 times 4 is 12 plus 3 times 7 is 21.
That's a good question. That's actually a pretty good question. Yes, yeah, that's actually called a distributive property of multiplication. We will get to the same answer as well. Yeah, that's a possibility to multiply in. Do you want to see that?
Yes.
Okay, so another thing, this is really not, although it works, a distributive property of multiplication works really well if we can't perform the inside operation. Yeah, but okay, I'll write it down just so you can see it, but in this particular case, the most effective way would be to just do the brackets first and multiply and so on. I'll show it to everybody. So this is what your friend here had said. I'll write it down here. So 3 brackets 4 plus 7 minus 11. That's really interesting. So what she said is this, okay? Instead of performing with the operation inside the brackets, what she suggested is that we multiply it in. It's called the distributive property of multiplication. So if you multiply in, what happens? What's that equal to? It's going to give us 3 times 4, which is 12, plus 3 times 7, which is 21, minus 11. And now we only have addition and subtraction. We can add and subtract all of that. So that's going to give you 21 minus 11. If you can do left to right, it's going to give us 22 as well. Yes? That works, right?
That sentence it says distribute.
Yeah, so this is called, the multiplying in is called that's awesome. So it's called the distributive property of multiplication. That's awesome. Okay, good. Yeah. Let's take a look at example number 2. What operations do you see in here? addition, subtraction, and multiplication. And multiplication is shown by the brackets. Now, it's kind of interesting, you know, when we were much younger, most of the time our multiplication looks like this, right?
Yeah.
Yes? Our multiplication used to be an X, right? And then later on, they changed it to, it's also the dot that shows multiplication, right? You can go 3 times 4 or 3.4, okay? And then there's another way to show multiplication. It's gonna be 3 brackets 4. Now, why did they get away from using the X as a multiplication? Any theory? Any idea?
It becomes a
Becomes part of the algebra, right? Because when we get into the algebra part, linear function, we will talk about that. We're gonna say 3x plus 4, right? So now you're thinking, is that x? Okay, of course, I wrote it fancy. Is that 3x a multiplication, or is that 3x as x is a variable? So in this case, it's a variable, right? So another way to say multiplication, we don't sometimes still use x, right? But we're going to be using the brackets to show or indicate a multiplication. So what happens here? What are we going to do first?
Bracket.
Yeah, so brackets, I see brackets in here. In fact, there are 3 of them. But within this bracket, are there any operation?
Multiplication.
No. Okay, inside the bracket, there's no operation, right? It's just -4. It's just -5. It's just -2. So nothing inside the bracket to work out. So the next thing that we're going to do is times, multiply. So we're going to multiply these two, and that one. So here, remember our multiplication rule. Negative times negative is a positive. So it's going to give us positive 12. Okay. -1 times -5. That's going to give us positive 5. And then, oh, what happens here? There's a, you can think of this invisible one there. So 1 times -2 is -2. Now you're down to just addition and subtraction. So you got 12 plus 5 minus 2. It's going to give us 15. Yes, 12 plus 5, 17 minus 2 is 15. Yeah. Yeah, you can do 2 steps, or you can just go ahead and just do the next. Okay, so far so good?
Yeah, I got it wrong. I got it wrong when I did it. I got 60 plus minus
60.
I thought the brackets meant that
That
you
bracket
have,
is
that
minus.
you have to multiply those still, but I see. It's not it, right?
I think you're right. So you're doing -3 times -4, which becomes positive, so -12. There's your bracket off.
So let me take a look.
Multiplication right there, right? And then you've got a section here.
Oh, yeah. So you went continuing on. Okay. Yeah. So 12. That's the 12 part there, and then here this is going to be positive 5. So we just forgot to put the plus in here. And then this is positive 1 times -2 is
Same as I didn't see a plus in between.
Yeah. Oh, okay. Yeah.
So I just multiplied.
Okay. Oh, sorry that I messed up your stuff. Okay, I should have asked you first.
Sometimes do something like this just to kind of break it up a little bit. We should bracket off here. You're right, but the bracket says that's multiplication, and then
Yeah. Okay. So yeah, for sure. Oh, the answer key to this.
So it just kind of breaks it down.
So these ones don't have answer key yet, because these are examples. example. So the answer keys will be for,
Yeah, it's just
Assignment.
yeah, assignment, yeah. Sorry, I meant the answer key is only for the assignment, and then the examples we go through together. Okay, let's take a look at example number 3. What operations do you see in here? You got a brackets inside in here, and then you have an overall bracket. So what we're gonna do is we're gonna work the inside all the way to the outside. Inside brackets all the way out. So I'm gonna be -2, negative brackets, negative, minus 11 minus 13. Okay, so what would that be?
11 plus 18.
11 minus 13 is -2. Okay, -2. So we work that out. Now, whatever's in here, inside the brackets, here is just -2. 2 minus -2.
I thought negative.
Mm.
Is that right?
Is that, are you talking about the final answer?
Yeah.
Yeah, it will be -4. Thank you. Hold on. I'm not quite there yet. So 2 minus -2, that's going to give you negative, and then here this gives you 4. Is that okay?
Yeah.
Yeah? And then you got a negative, and that becomes -1 times 4 would be -4. Yes, -4 is the final answer. Good, awesome. Take a look at example number 4. What's the first thing that we should do for this particular one?
Multiply. I mean,
What operation do we see?
subtraction.
We got the brackets, and inside the brackets is a subtraction. So and then the denominator here. So figure the numerator part first. So 11 minus 3 is going to give us 8. So 2 times 8. The denominator here is negative. What would this be?
Minus 4.
-4. So work out the numerator to the simplest as possible. Now 2 times 8 is going to give us 16. Negative times -4 is +4. So that's equal to 4. So 16 divided by 4 is 4. Okay? Is everybody okay so far?
Yeah.
Yeah?
Isn't it a negative though? The -4? Because the negative
This one or this one?
1 times -4, -4 is -4.
Yeah. Negative times, and the negative is
Oh,
a
it's a
positive. Yeah.
negative.
Yeah.
Oh, okay.
Yeah. You got the negative inside. It's a negative. Okay. Yeah.
It's fine.
It's okay. That's why we're going over this as an example, and we're going to go over some practices, right? Yeah, for sure.
When the multiply, do I have to put 1 or just I'm given that there is 1?
Yeah, yeah. That's a good question. Thank you for saying that. The question was, do I have to put a 1 there? No, you don't have to. But sometimes some people like to understand that there's a 1 there. But if you're okay without it, that's perfectly fine. You can just go negative brackets -4. That's okay too. Okay, example 5. What operation do you see in here? Get multiplication, addition, division. Okay, which one are we going to do first? Brackets. So within the brackets, it's just -9, right? There's nothing to work out there. There's nothing to work out there. There's nothing to work out there. So even though we see lots of brackets in here, nothing to work out within inside the brackets. So what's the next one?
Minus 3 times 7.
You can do the multiplication and division, right? You can multiply here. So this is going to give us -21 plus this one in here. This is 24, the division would be negative 3. And then this is minus negative 2 times negative 9 would be positive 18.
Excuse me.
Mm-hmm. Yeah.
24 divided minus 8. It's minus 3. Why put in bracket?
Yeah, you could put it inside the brackets to indicate that there's a plus. This is that plus right there. And then this indicates that it's a negative 3. Yeah.
Oh, because there are two signs. That's why.
There are two signs, yeah.
That's why.
Yeah. Okay. So, negative 21 plus negative 3 minus 18. Now you can simplify this as negative 21, and then this is going to be 1 times negative 3 is negative 3 minus 18. So negative 21, so that's going to be negative 24 minus 18. It's going to give us negative 42.
Question.
Yeah, for sure.
So if you're timesing those two negative 2 times negative 9, isn't that positive 18?
Yes, that's right. So,
Okay, so
yeah,
now you're
so-
adding a positive 18 to a negative 24. How is that work?
okay, so this one would be the negative right there, or the subtraction. And if I want, I can go like this.
Oh, okay.
Yeah. Yeah. But I already know that it's a positive, so yeah. Yeah, that's a good question, right? Those are, you're pointing out some good questions that other people are probably wondering about what those things are too. Example 3, yeah, for sure.
If you're taking negative 2 away from negative 2 and then you get your negative 4,
Oh, okay, so let's,
now you times that negative 4 by negative 1.
okay, let's take a look at this one.
Positive 4 the answer, not negative 4.
Okay. So here's the other thing, because I think I jumped too far. So negative 2 is still out here. This is the one that I like to put negative, I like to put the 1 there. So if that's the case, then it's going to be negative 1 times negative 2, which is a positive 2.
I get it.
Yeah, okay, I'll just finish it off. So anybody could look at this and figure out, yeah. Oh, sorry. This one should be, that one shouldn't be there. And then the negative 1 is still there, so it's negative 4. Yeah. Good? Is everybody okay? I'm doing all of these in calculation. Now, do you have a calculator? Oh, just a regular calculator.
I borrow if you have another extra.
If I have an extra one?
Share the
Sure.
one over.
Sure, yeah, thank you. Now, if you don't have a calculator, maybe your neighbor has something there, some kind of a calculator. Can you just type this in onto your calculator? Just type the whole thing. 3, open brackets, 4 plus 7 minus 11 onto your calculator. See what number you get.
That's weird. It wouldn't let me put 7. I'm just trying now.
22.
22. Yeah.
Does it?
Oh, see, it won't let me.
Oh, you know what? I think there's something wrong with this calculator. Go ahead.
Okay. Is it 3? Yeah.
Did everybody get 22?
Yeah.
So your calculator is a scientific calculator, and it actually works and does the orders of operation for you. Okay. Now, try the next one. See if you can do the next one. The last question, this one? You got 8 as your final answer?
Like 3 times 4
Yeah, sure. Which one? 2? Okay.
Let's give that a try. Okay, so if you're having issues with your calculator, if you have any questions, Adele and I can come and answer some of your calculator questions. So give it a try. You can try the example number 2. How do you do that on your calculator?
That's the only thing I wish you could like erase just one with your keyboard. Okay. -3.
Yeah.
Yeah.
Okay. Did you get 15 on the second one? Yeah? Okay, good. Now, I'm gonna jump. I'm not gonna do the number 3. Jump to number 4. Okay? And I'm gonna anticipate
So you would
something
you would
different.
do the top one first. So 2 bracket 11 minus
So type in your number.
and then divide. We got 4.
Okay. Did you get 4?
Yes.
Did anybody did not get 4? Did anybody get Oh, you get 4 again. Oh, everybody got 4, 4, 4. Is everybody okay? Oh, this one is weird one. It always gets 4. Everyone's okay?
Yeah.
Yeah? Okay. Now, for example, number 4, it works out as 4. But if you see something like this, when you have a numerator and a denominator, what we're gonna do is we're gonna do it in a 2-stepper. Figure out the numerator first, and then figure out the denominator. And once you have those 2 numbers individually, then you can divide. Okay?
So the top and the bottom.
Mm-hmm.
Still on number 4? Yeah, okay. So the top first.
Oh, no, just work it out. The numerator is-
Yeah. Or I think you're supposed to write it out like that.
Oh, no, that would be 3. Yeah, 2.
Yeah, and then don't forget to write it down. And then equal 16. Yeah, start over and then the bottom.
Okay. That's a good question. So this is -1.
Okay, 16 divided by yeah.
That is 19.
That's a good question. Okay, here's another question that came up, and I get asked this. How do I know if it's a negative or if it's a minus? How do we know if it's a negative or a minus? Like this one over here, let's try this one. What would this be?
Negative.
Negative. Why is it negative?
Because there isn't a space.
There's isn't a space in between?
Yeah.
Okay.
There isn't a
Yeah.
number behind it, in front of it.
And there's no number before it, right? So it's negative because there's no number before it. What about this one?
-4.
-4 because it's
Bracket.
a bracket. It's multiplying by a -4. What would this be?
Minus.
It's -1. This one? -5. Yeah. Okay, good. Let's take a look at this part in here. Now we're getting into the word problem. It says here our final example 6.
The wording can get confusing, especially because I think sometimes
Example number 6. You're a woodworker who makes chairs. It takes 3 hours to cut the pieces and an additional hour to glue. How many hours would it take to make a set of 8 chairs? So, how many hours can we... Any ideas on how can we figure this out? So here, we're gonna cut the pieces is 3 hours. So 3 hours. Glue is 1 hour. So now, to make one whole chair, you're gonna need 4 hours together. So total is 4 hours for one chair. Now, how many hours would it take to create 8 chairs? It's gonna be 4 times 8, and I use X. I should be using this. Okay, so that's gonna give us 32 hours. This is okay to chop it down into 2 different steps, 2 different parts. If you like, you could go like this, 3 plus 1. So that kind of gives us, I gotta figure out the total hours first to make one chair. And then now that I have that, I can multiply by 8. It's still gonna give us 32 hours. So here is put together in one line, and then this one is worked out. So far so good. Let's take a look at example number 7. To prepare for a healthy living conference, the teacher are stuffing swag bags. There are 400 bags in total. Each bag needs 3 bookmarks to put in the bag. If there are 1,300 bookmarks, how many will be left? How many would be left over after the bags are filled? So inside one bag, how many bookmarks?
3.
This is one bag, and you're gonna have 3. Okay, how many bags are there altogether? 400. So we know that it's gonna be 400 times 3. That means that's 1,200 bookmarks needed, right? But if we have 1,300 to begin with, and we're gonna use 1,200, how many are gonna be left? 100 bookmarks. Now, because this is a word problem, we want to make sure that we have the quantity, which is 100, and the unit, which is bookmarks. 100 bookmarks. Any questions there? Example 8. Matthew works in construction. He needs to cover 3 rooms with ceramic tiles. The rooms have floor measures 450, 350, and 200. Matthew knows that he can cover 100 square feet per hour. If he earns $15 per hour, how much will he get paid? Any ideas on how we could do this?
Add the square feet together
Mm-hmm.
and you get 1,000.
Okay. Okay, so hold on there. So I'm gonna add the feet together, the area. Oh, too much 0. Okay, and you said you're gonna have 1,000 square feet. Okay, next. Yep. Okay, you're gonna let somebody else do it. Okay. Okay, she started off.
You divide by 10 hours.
Divide by
10 hours.
10 hours. Yeah, we are gonna divide, but we're gonna divide by, I think you're giving me the answer 10. So you're gonna take 1,000 square feet divided by 100, because that's how many you could lay down in an hour. 100 feet, square feet per hour. Okay, that's gonna give us the 10, and that's where your 10 come from. 10 hours. It's gonna take 10 hours. Now what's next? What's the third part?
Times 15.
Okay, that's what she was gonna say, times 15. $15 per hour. So it's gonna be $150. Good. See, you can do it all in 3 different steps. Okay, next one. Who would like to start this off? Yeah, for sure.
What about like the 3 rooms? Would it like, that's what I got confused about.
Sure.
The guy's getting ripped off.
You have to add the whole
$150 for 1,000 square feet of tiling. Get out of here.
Oh, I just thought you were working like on 3 rooms and sorry.
Oh, okay, okay, no, okay, sure, that's okay. That's why we ask questions, right? We want to clarify things. Oh, can we figure out what is a square feet? How big is a square feet?
32, let's see, a square foot?
Yeah.
A foot by a foot.
How big is a square foot? How big is a square foot? 12 by 12, 12 inches by 12 inches. And if you look down on the floor, if you look down, can you see the tile? That's a square, right? That's actually 1 square foot. So this person can lay down 100 of these tiles in an hour.
That's where the grab, Joe.
Okay, yeah. Okay. Now you have a context. Well, what's a square feet? Well, what's a square feet? A square feet is a foot by a foot, which is, if you look down, that's a foot and a foot, right? Each tile. So he can lay down 100 of that per hour. That's pretty fast.
Yeah.
Still. Okay, example 9. What do you think we could do first? Carrie drives a truck for a living. Her average speed is 90 kilometers per hour and drives 8 hours each day. How many kilometers can she cover in a strand of 5-day work week?
Figure out how much you drive in a day first, which would be 90 times 8.
So we figure out how many she drove first. So 90
Times 8.
kilometers per hour times 8 hours. Okay, that gives us 720 kilometers.
And then we just
And then times it by 5. Yes, thank you. 720 kilometers times 5 days per day. So that's going to give us, help me out,
3,000.
30, 3,600 or 3,600? What would that be? Unit kilometers. Okay, fantastic. How do you feel about that? You're okay? So much of the applied math topic or applied math question is not just here's a whole bunch of numbers, calculate this. Much of the questions that is going to be involved throughout the course is here's some kind of a word problem, and then we have to decipher those questions, those information, put it into appropriate operation that we need to do, and then figure it out. Okay? So I'm going to pause right here.